Hello, everybody, and welcome to SQL Bits 2020 virtually. Got a very special session today, late to the agenda. We're going to talk about containers. And with me, I have Anthony Nocentino and Andrew Pruski.
Hello, Rob.
And they are, with all of this amazing container knowledge that they have, they're going to answer the questions, some of which are the ones that they DM each other about. It's going to be fascinating. So, guys, first question from me is, how did you get into Docker and containers?
Do you want to grab it? Or do you want me to grab it, Andrew?
No, I'll go first. Yeah, no worries. Okay. This was last job I was working in, and our QA department had a real problem refreshing their test environment. And their test environment was a whole bunch of VMs on some really old hardware that they were blowing away and rebuilding from scratch. And it had their full production stack on it. Each one meant that it had to have an instance of SQL Server running. And constantly blowing these things away, rebuilding them, reinstalling SQL. And because of the hardware and the process they were doing, each VM took around, say, 40 minutes to an hour to build. Whoop. That was my phone. It took about 40 minutes to an hour to create these new VMs. And the main instance of that was installing SQL. And all they were trying to install was the database engine. So I started researching how can I get an instance of SQL Server up quicker and quicker than the process that we had. And I stumbled across this technology called Docker. Started playing around with it. And I think the big light bulb moment for me came on when I first spun up my first container in Docker and watched SQL Server come up in about 10 seconds. So if we're trying to blow these VMs away each time and rebuild them on a regular basis, and the pain point is installing SQL Server, then this technology that can give us a new instance of SQL Server in a fraction of the time it was costing us, then that just seemed the way forward. So it just went on from there.
Excellent. Anthony?
So funny enough, the first time I saw containers was when Andrew presented at GroupBuy, I think it was in 2017, about how he was using containers. And I was like, wow, this is really going to be a thing, right? So you can see how quickly you can deploy, how quickly you can scale, I don't say scale out, but deploy multiple instances and things like that. And in addition to seeing that there in that conference, I also was at a Microsoft event about a year later where I saw big data clusters for the first time, especially sitting on top of Kubernetes. And that's when it really kind of all came together and caught my attention, as that's how we're going to be deploying systems in the future, right? And we're kind of seeing that emerge with big data clusters, now also with Azure Arc Data Services, that Kubernetes and containers being that underlying substrate to build those more complex distributed systems. And seeing how we can do that so easily and so quickly in code is really what caught my eye a couple of years ago.
Awesome. So you two are both using containers within your professional life. Let's talk about something deep. I mean, I'm sure anybody who wants to go and see your Pluralsight courses about Dockers, or your other sessions or blog posts about Docker, can understand how to begin to use a Docker container in some of the initial setup points. So I'd like to talk about some things that are really important to DBAs. Like, I used to be a production DBA, working alongside Andrew, as it happens. And, you know, first, perhaps the second most important thing to a DBA is performance. So what are the considerations that you guys would say are most important for a DBA to understand about running SQL Server in a container?
I'll take that. Well, I think we've got a big "it depends" running there. Depends how you're running it. Windows containers are a whole different kettle of fish. If you're running Linux containers, there's really no performance impact, because all Linux containers are processes running on the host. So there's not really any penalty there. So if you're going to spin up SQL Server in a container, you're pretty much just running it as a process on the host, and you're not going to get a performance impact there. Moving over to the Windows side of things, Windows has this concept of Hyper-V containers. And so if you're running SQL Server in a Hyper-V container, you are actually running it in a stripped down, lightweight VM, and there will be a performance impact there.
Okay, so
So
I'd like to challenge that. Sorry, Anthony, because I know you want to come in, but I want to challenge that statement first. First of all, in your professional experience, what is the percentage between Linux containers and Windows containers?
in data platform or across any
In data
application?
platform.
I haven't come across the Windows-based container the only time I ever see them is on GitHub when people are asking about Windows containers in SQL Server.
Exactly the same here. I started off using Windows containers, and then I saw the startup times of Windows containers, SQL Server especially, compared to Linux containers. And since then, it's all been Linux for me.
Yeah, and this
startup. So I myself have used Windows containers that Andrew made merely for testing DBA checks.
Mm-hmm.
So I'm going to throw your statement back at you because you said that Linux is just running as a process and it's all okay. All right. So if I throw my 1 petabyte database at it, it's just going to work fine. That doesn't sound right to me.
Well, it'll work fine as a petabyte database will work in SQL Server. You're just attaching a database to an instance of SQL Server, whether it be running in a container or on the host natively.
But as a DBA, I'm going to be looking at things like how much RAM, what's my network performance, where do I need NICs, what my storage performance is. So what sort of things do we need to consider with those with containers?
Let me grab this one, Andrew.
You want to take that one? Yeah, sure.
The way that I've drawn an analogy that most DBAs already understand is when people work in VMware, you still have to do resource planning in VMware, right? When you have your cluster, I need to make sure that I have the right number of nodes. I need to have a redundant number of nodes if one of the nodes pops off. I also have to go and make sure that I have the appropriate CPU memory available and in the disk subsystem. Well, guess what? It's nearly the same exact song inside of containers because you're going to be consuming those resources in nearly the same way. So what Andrew was alluding to is this concept of the process isolation. It's just a process that starts up. That's all a container is. It's basically a piece of software that said, start up the SQL Server process on that computer, right? And what a container orchestrator like Kubernetes does is it figures out which computer to start it up on and also kind of does some rudimentary load balancing of the workload, right? But we as DBAs still have to go and do that math. One of the other analogies I draw to folks is when you're especially when you stand up multiple instances or containers on a single host is back when you build larger scale failover clusters, you had to do kind of some workload balancing to make sure that if you're running a multi-instance failover cluster that you had enough CPU and memory across the 2 or 3 nodes in that cluster. So those same ideas still apply. It's basically the core thing that's changed is how you deploy that thing, the container, versus how you would deploy a VM and then Windows and then SQL Server on top of that. It really shortens the stack and gets you closer to the base OS. The perf stuff with the overhead of virtualization, I think that's probably negligible. I think we've all absorbed that over the years as just part of doing business. But yeah, there's really no fundamental differences there. So that analogy of VMware clusters is how I've been kind of educating people, DBAs that understand that from that experience.
So you can't really just shove it in a container and expect it to just be fine. You still have to do all the exact same things that you would do beforehand. So we're setting memory limits in SQL instance, and we're doing our index maintenance, and we're doing our performance tuning. But then we've also got options on when we run the containers themselves. So we can limit the CPUs available to the container. We can limit the memory that's available to the container, because we're not going to just typically run one container on a host. We're going to run a whole bunch of them. And we don't want to end up in a situation where one container starts taking all the resources of that host, and we have that noisy neighbor thing where the other performance of the other containers then starts to be affected by that one just grabbing everything, especially when we're running such a resource-intensive application such as SQL Server.
Yeah, and that's one of the core things, and I've blogged about this a couple of times, that's different in especially Linux containers when you compare to Windows containers, or even just Windows as the base OS for SQL Server. SQL Server and Linux treats memory pressure a little bit differently than it does in Windows, right? In Windows, we're used to just, if we see external memory pressure, the caches tip over and the caches dump and everybody's happy. In Linux, it's a little more diabolical in that it'll it'll reduce its cache size, but if the memory pressure grows too fast on a host, it's possible that SQL Server will page out. And I've blogged about that ad nauseum. The key thing, though, when you're talking about doing this in containers in Kubernetes, especially in Kubernetes, there's no swap. So that process can get killed. And so doing that math ahead of time to make sure that you have an adequate amount of memory to support that, and then also understand the other workload that's running so you don't put your systems in scenarios where the host is suffering from external memory pressure is critical. And so again, trying to draw back to the VMware analogy, in some shops, and even the best practices documentation for VMware says, put your SQL Server VMs in their own dedicated cluster because it's a like workload. And I would still advocate for that now if you have the resources to be able to do that. Again, because for two reasons: one, control, and two, learning. Like, we're all kind of seeing this develop and gaining experience with it right now. And so that way we can kind of observe how the system works and gain those learnings, I guess, in a more easily managed environment if it's just running SQL Server, right?
I think that highlights one of the most fun things it's been for us as DBAs over the last few years is, okay, we just used to have Windows, and that's where we deployed SQL Server. We didn't even question it. That was just the only, we didn't question it because we didn't have a choice. Now we have all these other different choices. We have Linux, we have containers, we have Kubernetes, we have serverless architecture like Azure container instances, managed instances. Where do we deploy? What are we going to use? And so we really have to have a look at each one of those platforms and see which one will be the best for our workload and how we want to approach an issue that we're having.
So it sounds like what I'm hearing is running SQL in containers is basically just like running SQL, and you still need to maintain everything, and you still need to monitor everything, and still need to plan, and there's going to be a lot for DBAs to do. But both of you have said that you've not seen Windows containers out in the wild. So that means we're using Linux skills. So I've always been a Windows guy in a Windows shop. Does that mean I've got to learn Linux now?
Yes.
Well, I think you're the good one to talk about this, Andrew, because you've been making that journey recently.
I'm probably, yeah. Good point, Anthony. No, I'm exactly the same. I was Windows DBA, lived in a Windows world, hadn't really even touched Linux. I passed the Certified Kubernetes Administrator's exam a few months ago, and I sent it to my mate, who said, well, you've come a long way from logging into Linux and going, what's going on here? So as I've seen these technologies come along, and especially the Kubernetes one, which was a real kicker for me, I just dived into it and just started learning bit by bit, and it's been, really good fun. So I wouldn't say it's, an absolute vital technology to learn at the moment, but I would say that it's coming where DBA should be learning the Linux platform, just because it's fun as well. It's a whole different thing to learn, and we're all in technology because we like learning new things.
Right.
I know you've gone the whole hog, and your laptop is running Ubuntu, and you went the whole way. Is that what I've got to do now?
You don't have to use it as your primary driver at all. I did that because I just wanted to, if I use it as a daily driver, I thought I'd get more used to it. Now, I know that's a bit, it's like saying, I run Windows 10 on my laptop, therefore I can be a Windows Server admin. But you still get used to the environment and working with it and things like that. I really like Windows 10. It's a good desktop, but I like playing around and investigating other things. So I've had Ubuntu on there, I've had Manjaro on there, I've had Fedora on there, and I've just wiped it yesterday and gone back to Ubuntu 2004. Mainly because of Dell XPS, I have Wi-Fi drivers don't particularly work in any other different, but it's still kind of fun.
Okay, so if I'm not interested in running my OS as another operating system, but if I was to use WSL, and would that be a good way of me getting into learning how to use it?
100%, especially with WSL 2 that's come out now, which is basically a full-blown Linux kernel running on your desktop. That's absolutely great because it means you can go in and you've basically got a Linux distro there that you can play around with. Docker's compatible with it. Absolutely have a look at WSL.
Exactly what I do. Okay, so I kind of understand now that this container and SQL thing is just like having SQL servers, and vaguely an analogy is I'm putting VMs on a VMware if I'm putting containers onto a host. So you guys both say things like you provide isolation, containers provide isolation from the base operating system. Can you describe to me how that works and why is that important?
Is that you wanting that one, Anthony?
Well, it's almost like you just taught a session on it at this conference at SQL Pits this year.
Yeah. So yeah, there's a whole load of things about Docker is an isolated environment that just contains all the binaries and libraries for a application to run without it talking to anything else. And so there's a few concepts in the Linux world that provide that isolation. So you have starting off with control groups, which we mentioned before, before with how Linux controls access to resources on the host. So Linux in the background uses control groups to limit the access of containers to resources on the host. And then there's namespaces. So if control groups control what a container can use, namespaces control what a container can see. So by putting a container in different types of namespaces, you control what that container can see of the host. For example, if you go into a container and have a look at the host name, you'll see it's different than the actual host name of the host the container is running on. And that's because it's in a namespace, specifically the Unix time-sharing system namespace. And there's other namespaces as well. There's things like the process ID namespace. If you go into a container and have a look at the processes, you only see a subset of processes that are to that container. You don't see all the processes on the host. If you jump onto the host, you can actually see the processes in the container running there with different process IDs. And that's because they're in a namespace controlling what that container can see. So we have control groups limiting what the container can use, namespaces controlling what the container can see, and then finally, we have the root of the container. Now, the file system that container sees, it doesn't see the entire host file system, it just sees a subset of it, because that container's root is changed upon startup to a different location on the host. And you can go in and you can investigate and have a look and see where that container actually is on the host. That container thinks that is the root directory. So by using those three concepts, that's how containers get isolated from the host itself. Anthony, is there anything you want to add to that?
That was perfect. I'm so glad that we're going to have this as a recording because I'm going to listen to that again.
Okay, so...
Well, I do want to add, that's fundamentally Linux containers. Windows containers do take a different architecture, and there's two variations inside of Windows containers on how they're implemented, both Hyper-V containers and what's the other container type called? I forget.
It's still process isolation, but it's Windows process isolation. Yeah.
Yeah, so the concepts that Andrew just described translate over to the Windows side of the house for the process isolation one, and then Hyper-V adds basically another wrapper around that, of additional layer of isolation at the host level, so someone on the host couldn't see the processes from each other's containers, like you just described that you could on the Linux side of the house. So it's really the only caveat there. Yeah,
the Hyper-V isolation it's basically a VM. Containers all make system calls down to the kernel, but if they're running in Hyper-V, they don't. They actually have a kernel in this. So it's a really isolated environment. Really good if you want a really cut off environment just to do your testing, to make sure you don't do something silly like I did earlier, which was what did I do earlier? I was testing some process with security, and I managed to block access to my Etsy directory, which meant I couldn't do anything on it, and I had to blow the whole thing away.
Do not reboot.
It was an Azure VM. It just blew it away and stuff.
Oh, okay.
Yeah, I was doing automated deployments of permissions with Azure DevOps to Azure SQL Database with the service principal today, ready for my demo, and managed to lock myself out in my Azure SQL Database completely. Yay! Test what happens if I take away all the permissions.
Yes.
Okay. So yeah, I'm glad that we have a place where we can do those things, where we can throw them away. But it brings me back to this session, and obviously the automation of deployment is something that I'm very interested in. It's a part of this world that really fascinates me and I enjoy. So when I'm looking at deploying SQL containers, and I'm not talking about just for demos, but let's talk production. Let's do this for the people who are really working with containers in production. How am I supposed to deploy it? Do I use Docker Compose? Do I use Kubernetes? Do I do something other sort of orchestration? What is the best way forward? And hey, isn't it complicated?
Well, yes. If you're going to, so what I've been evangelizing to folks is if you're going to do containers in production, it's going to be on Kubernetes. And within that, you have to decide, am I going to use straight Kubernetes, like the actual open source project? Am I going to do it in the cloud with a managed provider like AKS? Or am I going to go and get a supported vendor package like OpenShift? I think that's kind of the first question that I kind of get into. And then the benefits that you're going to get from doing this in Kubernetes is the automated deployments in code, right? You're going to write code that describes your systems, declarative state, all that fun stuff that, we want to get our hands on by using this kind of technology. So that's really, if you're going to do it in production, I think that's the first step, is getting familiar with Kubernetes, writing code to do it, building good monitoring and metric systems to clean your data out so that you know what's going on, and go from there. Like that's really step one for me. And so obviously the resource stuff that we talked about a few minutes ago.
So you had three choices you gave us there. Could you just run through those a bit slower and explain what they are?
Sure. So say straight or vanilla Kubernetes. That's literally the open source project that we can download and deploy on our laptops, on VMs in our own data centers and things like that. So it's an open source project, started in Google, released to the community, and is now supported by the community, much like any other open source project. That's where I spend probably 90% of my time, is in straight Kubernetes. But that requires a lot of hand-holding, right? Of being able to build a cluster, maintain a cluster, and knowing all the ins and outs of doing that. The next big bucket would be
what do you mean by cluster?
A cluster is a collection of compute resources aggregated together that you can deploy workload into. So not unlike a VMware cluster, again, it's a collection of computers that I can just say, hey, do these things. So rather than create a VM, you're going to create containers or pods running on top of that cluster, which then can be scheduled across the many different nodes available to you. How many can you start? Well, that depends on the resources that your application consumes and how much resources you have in that cluster, right? So that's native. So that concept exists regardless of how you deploy Kubernetes, the resource management. The next big bucket where I'm spending a little bit of time is in the managed service provider, specifically for me, because of my background, Azure Kubernetes Service. That's where I'm spending some time. And so what that means is I go to Azure, I'm like, hey, give me a Kubernetes cluster. It goes and provisions that, and then I can just deploy workload. And I don't have to worry so much about the ins and outs of the cluster deployment and management. I get the benefits, the management benefits that Azure provides for me to deploy workload into that. I do a lot of work in there. And then OpenShift, which I have zero experience with, is kind of a corollary to the open source Kubernetes, the vanilla Kubernetes. OpenShift is a package that's available from Red Hat that you can then deploy on-prem or in the cloud, but that gives you support contracts and someone to call. If you're in a regulated industry, that becomes valuable to you. There's other players in that game, but in our kind of Microsoft data ecosphere, that's where a lot of people are going. Not a lot of people, but that's the main player in our ecosphere, I would say.
I'd 100% recommend people go and check out Azure Kubernetes Service, if they're especially just getting into Kubernetes. I remember the first time I was playing with it using the Azure CLI, and you can just spin up a cluster with, I think it's 1 line of code, 2 lines of code if you create a resource group beforehand, and just go bang, off it goes. 10 minutes later, bump, there's your cluster. This is how you connect. Have fun. And I was like, oh, thanks very much. So yeah, if you're looking just getting into it, definitely recommend starting off with a managed service before you get into building your own cluster with kubeadmin and deploying kubelets and things like that.
Okay, so thinking again at a sort of enterprise level where we're deploying these containers, how do you guys work out where the problems are? I know we can set up this system so that if a container dies, we just spin up another one, and we're always going to have so many available, et cetera, et cetera. But this is tech, and sometimes stuff goes wrong. So what are your out of the box methodologies for going and finding out what's happened?
So with the infrastructure I built in a couple of jobs ago, where we were just running one Docker host with all the containers on there, we did have issues. I guess one of the reasons Kubernetes exists is because when you get like 50 containers running on a host, it gets a little bit difficult to manage. We were using Portainer over the top of it, where you can actually just log in and check and have a look at everything that's running very simply. Other monitoring things out of the box for stuff like Kubernetes, that I think every other day there's a new tool released for Kubernetes, but one of the best ones is something like Prometheus or Grafana, where you can overlay that on top of your cluster, and it'll just, I think it deploys a daemon set. I can't remember off the top of my head, but it collects so much information that you can just spread on dashboards, and it'll give you a really good overview monitoring of your system. I think AKS is a built-in tool as well that you can monitor with, off the top of my head. There's the default Kubernetes dashboard, yeah?
Right. And you can put it into log analytics as well, can't you, in Azure?
That's it, yeah.
Yeah. And so that, I guess the production challenge that you have to solve is log aggregation and data aggregation. So log for the stuff that's being emitted by your applications in SQL Server, and then also the aggregation and analysis of performance data. And so Andrew mentioned Grafana as a charting tool, right? But that's the display. Commonly, you'll see Prometheus as a tool to collect perf data off of containers and nodes. And then also Kibana is a tool to aggregate logs. And the reason why this becomes unique in containers and Kubernetes-based deployments is because of the ephemerality of the deployment. Things can change, things can get deployed again. You can scale out, you can scale down. The idea, though, is the container that was running 5 minutes ago, if it dies and goes away, that container is never coming back. You're going to get a new container in its place. And you have to have a tool to kind of stitch that story together about that application, because you don't really care about the lifecycle of the individual container. You care about the collection of containers that are supporting the service that you have access to. How is this service performing? What are the logs associated with the pods or the containers running behind this service? And these tools help you solve those problems. And that's unique from what we saw, especially in the Windows side of the house. We're so used to going to PRD SQL 001, looking at its charts and maybe opening up its perfmon and collecting its event logs. It's a different paradigm in how data is collected and then consumed by us.
I think Anthony hit on a real good point there of we don't care about the individual containers. And that's one of the things I really like about these new technologies is as SQL Server DBAs, we're used to lovingly installing SQL Server and tweaking it and, whispering to it sweet nothings and making sure it's okay. As this technology changes that, like, I don't care about those instances anymore. Those are completely replaceable. What I care about is just the data files, the data and the log files. The SQL instance that's attached to them at any one time, I don't care about. I can spin it up from a custom image, knowing that it's configured exactly the same as the previous image that was running in there. I can blow that one away when I'm ready and bring another one in straight away. I don't care about those instances anymore. It's just a different way of thinking about SQL Server now, I think. We've separated the compute from the data completely.
So what I'm hearing you guys saying is, we don't care about our instances. They just become the true cattle of this world, and we don't have any more pets. And I'm fine with that. But also, if I replay this back to you, what I heard is that when I'm looking at investigating a timeline for an incident, I'm no longer needing to go to specific machines or logs for specific machines. That I'm actually going to use some sort of tooling that's still going to enable me to have that timeline of what happened when to be able to investigate how it all works. I've just got to learn to do it in a different way.
Right. Yeah. You're still stitching that story together. That's what we've always done. We're pulling logs from A, B, and C and helping us resolve the issue. I think in this scenario, the key fundamental difference is because the log needs to be decoupled from the life cycle of the pod or the container that it's running, that it becomes unique. Well, to us as DBAs.
So DBAs think things are important. I mean, obviously, number one thing that's important is backups, and we you know, this is just SQL, and we have backups, and we need to deal with them to storage accounts, and easy. We've talked about performance and how we still need to analyze and prepare and monitor the performance. We just may be doing slightly different things. Let's talk about security. Now, obviously, one side of security is our access to our data, which is exactly the same because it's just SQL.
Mm-hmm.
But what about if we take it down the level to our container binaries? What's our risks here with just grabbing these binaries?
So when you say binaries, do you mean like the images that we're deploying and the applications? Is that what you're considering?
So it kind of ties into another question, which is sort of similar, which is where do I get my SQL Server from?
Okay.
Because
yep.
You want me to get it?
No, you can go for it, man. I would say you could start off by looking at the Microsoft SQL images that are available on the Microsoft Container Registry, but I would 100% recommend building your own container images and storing them in a private repository.
Yeah. So I try not to make an analogy back to the Linux world, but
good luck.
all right. So, all right, well, maybe you've installed a package from like Yum or apt, right? And you've downloaded something, and the first thing that you do, or when that package gets installed, is the package, whether it's apt or Yum or whatever, when you're installing a piece of software, is it checks a hash to make sure that software hasn't changed from when it was published by the software publisher and stored in its repository, right? That same concept applies in containers. Yes, Rob?
So you mean like as a Windows person, when I go and download some software, I go and check the hash and then do a comparison to make sure it's the same?
Right. You want to make
an exe.
Yeah, you want to make sure who put the thing there is the thing that you're getting down. And in containers, that same exact thing exists. And so each container image will have a hash, and then the component layers of the container image will also have a hash, because it's possible that containers can share an individual layer for optimization of space. And so the first thing that happens when you pull it down, that hash is checked. If it's the same, happy, right? And you can trust that software is the same as it was put into the repository. Now, container security, we could probably spend the whole afternoon talking about that into the evening. But when you're talking about just getting and retrieving container images, that's the fundamental way that you can trust that what you're receiving is what was published, is the hash on the container image.
So is there not some danger here if I have that conversation with a security team that they're going to say, well, hang on a minute, we're sharing layers. What happens if one of those gets corrupted? What are our security risks here? Let's go as deep as you like. What are the things that are troublesome?
So, as Anthony alluded to, it would be pulling an image that's been corrupted in some way to do something nefarious. So you can check the hashes when you pull them down. I would sidestep that completely and not. If I was to, and we do this actually in my current work, is we don't deploy from a public registry. We have Nexus set up internally where we build and deploy our own images, and only those images can be pulled onto a Kubernetes cluster. So we just basically entirely sidestepping the issue with maybe some sort of issue with a public image and just going with our own custom images that we know haven't been corrupted.
Are you building? So I want to ask a question now. Are you building on top of your own? Basically, what are you building on? Like, what container image are you using as the first step of that build?
So the SQL instance that we're POCing now would be built from scratch from the Ubuntu 1804 image.
Okay.
So we take the Ubuntu 1804 image, pull that down, check its hashes, and then build from there. We actually run a container scanning tool as well to have a look at what possible issues are with that. image. And if that all checks out, we can then go ahead and we install SQL like we would install SQL on Linux. You know, you add the GPG keys, you add everything else, and then you start pulling it down and go from there. Yeah. So then you end up with an image that isn't from a public repository, that's running SQL Server that you've built, that you've stored in your private cloud.
Just like the proper way of any internal software, the place that we always aim to get to for these sort of things. You're saying follow those same good
Basic,
practices.
yeah, same as exactly. It's just a different type of technology. So follow exactly the same security precautions that you would downloading anything, really. You know, don't go to www.definitelyNotADodgySite.com and start downloading all this stuff.
Did you say definitely not dodgysite.com?
Yeah.
corruptedsqlcontainers.org. It'll be fine.
Right.
I think it's really easy to do. I mean, I've in the Docker Hub, I could push up an image up there to have anything in it and say, hey, I've got a new SQL Server 2012 image out. Go and download it. Boom, got something on there. I've now got something running on your machines that you don't want to have. So, yeah, be careful with the public images.
Yeah, and I think that's
I did just download the stuff that you uploaded, but again, I know where you live, so.
No.
Right. But that's a key concept that you just said, Andrew, is when you type Docker run or you deploy a YAML file that's pulling a container image, you're trusting the code that someone else built, compiled, made a container image and published. And that's a pretty big jump in trust to be able to just say, you know what, I'm going to run that code on my platform inside my data center, right? Think about the security implications of doing that.
Attached
very
to my
rare
production databases. Yes.
Yeah. So don't, as easy as it is to do all of this cool stuff by typing Docker run or downloading a YAML file that's already pre-configured, you're still, I mean, what is it? The age old adage of, don't just copy and paste that thing off the internet and run it. Know what it's doing first before you do it.
There are cool tools out there. I think Nexus has, when you push an image to it, it will automatically scan that image for you and tell you of any possible issues and vulnerabilities that are in it. So it's kind of cool to see all the vulnerabilities that are in the official Microsoft SQL Server images, but still, we won't go there.
Okay, so let's carry on down this path. So now we've got a nice, safe and secure container from validated binaries. We've installed our SQL in the way that we want it installed with everything that we want. We're locked down access to our production databases. We've got always encrypted in. We've got all of this good stuff going on. But I don't really know Linux. I've said this before. And, we've got this situation where I understand the SQL part and I can deploy that part. But SQL's running in a container that's running Linux on a host that's running Linux. Other people are probably going to be the ones administering that underlying host and looking after it. Can they get at my data through? Is there risk here?
Well, you'd say it's the same. I'd say it's the exact same issue with Windows. If you have sysadmins who have full admin access to your database servers, they can get at your databases. And so it would be the same in the Linux world. If you have sysadmins with root access to your hosts, then yeah, they can get access to your databases. So it's kind of just shifting one problem from one environment to another. You just do the usual steps that you take. You don't have things like local administrators have access to your SQL instance. You don't run your service accounts as local admins on the box. You don't use the same domain admin account for all your SQL Server services across the entire estate. Things like that.
So I understand those sort of things, and as you and I both know, we go to great lengths to make sure that in those days our VMs were locked down so that our admins, as in our storage admins, our AD admins, sure, if they had domain admin, they could probably alter permissions and make it work. But we locked down access to the underlying storage and underlying data. We were in control of that. And because that was all Microsoft and Windows, I understood where I was going. If you gave me your container host and said, right, Rob, lock that down, I'd be like, oh.
Actually, do
How
a
do I
debate
fix
on.
that?
Oh, so,
How do I fix
so
that
I guess,
problem?
well, I think what you're getting at is like, what skills does the Windows DBA need to know in this Linux universe? Is that what you're describing? Are you getting at?
I mean, to be honest, I mean, I don't even know what the risks are.
Okay.
You know, I don't understand where the challenge is. I just know that there is a challenge.
Yeah. So for me, what I would want to see is, especially in a lockdown situation, is you need to understand users, like how users are created, how rights are assigned to users. File permissions is going to be a big deal. Making sure we understand, because it's a huge world of difference when you look at the octal notation associated with the Windows file, or excuse me, a Linux file, and no offense, Windows folks, but the collection of checkboxes that says allow, deny, read access. That's very easy to read. But what does Chmod 777 with a plus S on the end do? I don't know. But those kind of things are the skills I think that we're going to have to learn so that we can lock down a box. You know, who can get access to the system, and then what can they get access to, right? So users and accounts and files and permissions. One key concept that I do want to bring home about deploying containers, though, and talking about locking down hosts, is in the Kubernetes universe, these hosts are just going to be workers, right? We don't want stuff on these hosts. We don't want people logging into these hosts, right? It's very similar, again, but drawback to VMware. It's very few and far between will someone log into an ESX host to do something, right? And so it's that same idea. Do you lock it down at that level, right? Now, there's a little more commingling in the container ecosphere because of the isolation that Andrew described earlier. And so you would see those processes. And if there was the ability to get a privilege escalation or a rogue actor or an administrator that just doesn't know what they're doing, then those are all things that we have to engineer the platform towards to prevent them from causing outages and pain and things like that. And so learning how users get access to the system and how they get access to stuff would be the key ways skills, especially, that I would want to learn first as a Windows person to protect my data. Because as DBAs, that's our job, right? We have to protect the system because DBA
And we'd
means...
be the first. Don't bother asking.
No, but I'd say the concepts are the same for SQL Server running containers, SQL Server running on Linux, than they are on SQL Server on Windows. You know, I need to lock this down. I need to know who has access. Okay, how we do that is different. Well, that's a Google away, or a course away, or a book away, or a blog post away. So it's just a matter of, what do I want to do? How do I do this in this environment? And we go there and we just take it step by step, learning more and more as you go. And before you know it, you're sitting there typing away, sorting out sudo access, denying sudo access, even things like that.
So this has been awesome. Picking into your guys' brains is fantastic, and I'm sure there's plenty of sound bites here people are really going to take through. Got about 8 minutes or so left, so I want to split it in two, and I want to ask each of you individually, what's the most interesting question that you've DM'd the other person? I don't mind who starts.
Oh,
I know. There's been so much, honestly, because not even kidding. There's probably not a week that goes by or a couple of days that goes by that we're not chatting about something in this container world, you know?
Well, I could do the most recent one I was talking to you about, Anthony, was we had a issue with something called an Nginx English controller in our Kubernetes cluster in my day job. And it just had, I was looking at it going, there's something terribly wrong with this, and I don't know what it is. So I was pinging you going, have you seen this error message before? Because I don't know what this is. And you're going, try this. And we were walking through it, going, right, okay, what is this? It turned out to be a networking issue with one of the workers contacting the control plane of the Kubernetes cluster. And it was really cool because the solution was blow the node away. There's you don't fix nodes in Kubernetes. You blow it away and you put a new one there, especially as this is a managed instance. So it was actually EKS. So very simple to blow the node, cordon the node, move all the pods off it, blow it away, bring a new node in. We were done within 30 minutes. once we realized that it was a networking issue from us. So that was kind of cool. I'd like seeing that actually in action, this way of just saying, all right, I don't care about this. Go away. You're gone. Bring something else in.
Yeah, and that concept
is that the new have you turned it on and off again?
Pretty much, yeah, blown away.
No, that's
Sorry,
awesome. No, yeah, that's the key concept, because you think about it at the app tier, right? I can just blow my app away and deploy it again, get my configuration externally, have my state persisted somewhere in the cluster, or even external to the cluster. But that applies to the node. It's a very powerful concept, because I make this joke that like our troubleshooting skills are all going to erode because we're just like blowing things away and starting from scratch, which is kind of true, but not true, because we still have to figure out why, right? Then that Andrew, when in that same conversation, he's like, I want to figure out why that broke, not just how I fixed it, because you're going to see it again. And how do you prevent it from occurring the next time?
I was happy to blow it away once we realized there was a networking issue, but I didn't want to just blow it away without realizing down to what it was. But yeah, as soon as I was like, oh, it can't contact the control plane, I'm not even going to go there. All right, goodbye. Yeah, I mean, the actual site, the whole thing for that was, whilst I was blowing the node away and doing like investigation, the people I were working with actually spun up a whole new Kubernetes cluster, deployed to there, and got the production apps up and running. So I kept the other cluster to play around with to see if I could work out what was going on. So yeah, instead of like spending hours deep diving and working out what was wrong with it, they spun up a new cluster and just let me play around with the old one, which is kind of cool.
Do you want me to grab on my side now? Okay. So the one thing that we've been one of the cool things about Kubernetes is the concept that it can build self-healing applications. And even in the context of SQL Server, if your SQL Server dies, Kubernetes can put it back for you, which basically means you get failover cluster-like functionality for free in this Kubernetes platform without having to have a bunch of like highly skilled DBAs. No, I'm kidding. But the real concept there is that you can leverage the platform and its capabilities beyond just SQL Server, right? I can have web applications and all these other things running inside of Kubernetes to get that same functionality of self-healing. There's a concept in Kubernetes called pod eviction timeout, and that changed recently. And I was thinking that it worked this way. And Andrew wrote a fantastic blog post on how it changed and how it works this way. And so it's those kind of things that like we're constantly talking to each other about how these things work and the constant change that's happening in Kubernetes and in containers and even in SQL Server, and how we, that changed and it affects how this works. And that's a common thing that we're always DMing each other about is, have you worked with this new piece of thing, or why is it behaving this way now? It used to behave that way, right?
I had immense fun with that. That was me deploying SQL Server to Kubernetes and then just turning nodes off and seeing what happened. It was great fun. I was like, I'm going to change this setting here and see what happens. Turn it off. Oh, okay. Well, that completely broke it. All right, let's not do that.
Right.
No,
I guess
just
that
really,
is the number
really
one.
Fun playing around.
Yeah, and break it. Figure the chaos engineering elements, right? That you've been talking about. How is SQL Server going to react if this happens, and understanding that, especially before you go to production, because the last thing you want to have is this thing in production and it's doing something and you're just not ready to deal with whatever is occurring yet, right?
You should definitely use Space Invaders to do that then.
No, that's my favorite. Kube Invaders is my favorite GitHub project ever. Killing instances as a SQL Server while playing Space Invaders is just fantastic.
I every time I've been the same place where you are and you're going to do that session, I try to get in even just for that bit, because the reaction for the crowd is just amazing. It's so good.
That's such good fun. It's a really good fun way of finishing off a session. I really enjoy that.
Well, guys, you have been just amazing. Thank you so much for sharing your knowledge. Would you each like to tell the wonderful listeners how they can get in touch with you? Andrew.
Yes, absolutely. I'm all over Twitter. I'm at DBA from the cold. My website's dbafromthecold.com. Loads of articles there about running SQL Server in Kubernetes and containers. And if you have any feedback for me or just want to reach out, please come and talk to me. I'm always willing to talk about this stuff. So my email address is dbafromthecold@gmail.com. And I'll be hanging around SQL Bits quite a bit as well. So reach out if you want to.
So yeah, you can hit me up on Twitter at Nocentino. So it's just my last name. And I'm pretty much on there pretty frequently, but it's my main way to interact with the community. That's how I met these two fine gentlemen and pretty much everyone in the SQL Server space and in the Kubernetes space is via Twitter. So if you're not on Twitter already, check it out. I'm on the web at www.centinosystems.com/blog. That's where my community blog is. And feel free to just reach out and contact me in any way, whether it be via Twitter or via email at aen@centinosystems.com.